So our presenter today is Dr. Evan Bean. Dr. Bean is an assistant professor and extension specialist. He is located here in Gainesville. His focus is on urban water resources, engineering with emphasis on stormwater management and water conservation. He is leading in the direction of development and smart technology and water monitoring. He has gotten his education from North Carolina State University, as well as his PhD from the University of Florida right here. And he's an affiliate faculty member in the Center for Landscape Use and Efficiency, also known as CLUE, and he and I work together in that department. So we don't get to see each other enough, but it was fun
Definitely not
catching up
enough.
with you. Yeah, and now that maybe as we're getting through COVID, we'll be able to get together a little bit more often for faculty meetings and meetings together. So Evan, we welcome you to the Master Gardener webinar. We've been doing webinars like this since 2017. So we're in our 5th year of webinars, and we are so thrilled that you can join with us today. We have over 200 people logged in and ready to listen today. So I have stopped sharing. So if you're ready to share and get going, you can begin.
Well, thank you so much, Wendy, for that introduction. It was great to talk with you. I'm glad that now I can't see sort of that number of attendees ticking up, because I imagine sort of a lecture hall kind of in the real world that would be filling up, and trying to imagine 200 people. That's too many. It's too many. But anyway, let me get to the topic of today. I'm really excited and I'm honored to be invited to speak to you today about improving soil health. We've been kind of working on the efforts to improve soil health in the urban landscape, really through trying to incorporate compost and figuring out how much do we add, how much can we add and reduce water, and what are kind of the overall impacts of it. But first I want to start off by talking about, for one thing, why our landscapes or urban landscapes are, to be perfectly honest, pretty poor condition a lot of times. So a lot of times, if you go and you dig down into your soil, or you pull up, vegetation from the surface, you're not going to find really good soil unless you've been in a house for a really long time and that soil is kind of matured. What we end up having in Florida, one of the main drivers is development. We've seen it all over the place. We're back up to about 1,000 homes, 1,000 people per day moving to Florida. So populations continuing to grow, and with that, we need to have homes that are built to house those people. With that in mind, the land development process has gotten pretty efficient here in Florida. If you can't tell how fast homes are kind of going up, just kind of anecdotally talking to the development industry, it seems like we can go from flat lot to completed home in about 65 days. So we're talking about, if you have a flat lot now, you move in ready, invite me in for a cup of tea or something like that by basically June 1st. Okay, so pretty quick. During that time, this is kind of key to why we end up having sort of poor soils. During that time, the material that's been brought in, the fill soil that doesn't have a whole lot of organic matter, it's usually pretty coarse sand, or it's been dug up to excavate to create stormwater ponds. That material undergoes heavy vehicle traffic. So the vehicles working on the site, moving all the materials to build the houses. We also have Florida weather, wetting and drying, and I'll talk about the importance of that in this process here in just a moment. And then vehicles that just sit on the site vibrating, sort of just vibrating when those vehicles are running, and the particles of the soil are able to kind of consolidate together. Kind of going back to this heavy vehicle traffic, the vehicle vibrations, and combining that with wetting and drying. This is a plot, and don't get overwhelmed by it, but just kind of hit on the high points of what's important here. Number one, on our y-axis here, our vertical axis, we have the density of soil. So basically how compact it is. And on the right-hand side, we have the water content, how much water can be stored in it. You notice this orange line here is kind of the limit of how much water a soil of a certain density can hold. Okay, and each soil, there's different soil types here. You got 1, 2, all the way up to 8. But what's important is that each one of these soils is characterized by a hump. Okay, and what that means is that the maximum density here is not at the wettest or driest end of the range. Okay, if you think about a wet soil, or trying to compress water when it's saturated, you can't compress water. If you remember that from high school physics, right? And when you get to the dry end, when there's no water, there's too much friction between those particles that they can't just slide by each other. And so really what we want to have happen, if we were trying to optimize the compaction of the soil, is we would want this sort of pattern of wetting and drying, which we have with our Florida climate of afternoon thunderstorms, and then having vehicles or some other type of weight that then compacts it during those wetting and drying cycles to optimize that compaction until we get up to an optimum compaction or optimum density. And so that's really kind of what's happening in these landscapes, but it's also typically what we kind of do to compact a roadbed, which we don't really try to grow plants in a roadbed. So just to kind of put some of these parameters in perspective here, if we were to compare sort of new construction lot with an undeveloped forest, so basically native, or at least it's been native for several decades, comparing sort of those soils, what do those characteristics look like? So what you see on the right is a grad student, Casey Kowalski, who's trying to basically put all of her weight on this 1-inch diameter soil probe to get a soil core out of it. It's so compact that you can't get it in there. And somewhere out there, there's a photo of me doing one of these things. It's just extremely compacted in these a lot of these residential landscapes. So this depth to refusal is kind of an estimate of how easy it is to push a rod or push a soil sampler into the soil. And you can see with the undeveloped forest, 120 centimeters, that's really about 4 feet. Okay, so you can kind of, it goes down and that doesn't stop. Roots in this case means kind of roots can go very easily into the soil. With new construction, we're talking about only a couple inches. Okay, bulk density, we can see that bulk density is about 1.2 for undeveloped forest, and new construction 1.75. Keep in the back of your mind this 1.23. We're going to come back to that in just a minute. Porosity, this is basically how much space can be occupied by air or water. We're at about 50% of that volume for the undeveloped forest. We reduce that by about 1/3 in new construction. Organic matter, in this case, a lot of our Florida soils just aren't naturally organic. This is a pine flatwoods, well-drained soils, just naturally doesn't have a lot of organic matter. But then our pH, this is a key factor, particularly in a lot of our plant selection. Undeveloped forest, natural soils build up some tannins, some organics, and the pH is much lower versus the new construction, which in this case has probably brought some limestone to the surface and mixed it in, and that's why we get a little bit of a higher pH. A lot of times we'll see that this landscape pH gets up towards the 8 and even over 8 at sometimes. But soils can naturally sort of mitigate this this compaction effect over time, all right? And that's one thing that we did. We took some soil samples in a few different neighborhoods around the state, one down in Sarasota County and one in Marion County. I'm sorry, not Sarasota, Manatee County, and looked at sort of what the soil characteristics were for lots of different ages. And so that's what I'm showing here, and looking at basically what we have in the beds on the top and what we have in the lawns on the bottom. And so what you can see here is that starting at time 0, brand new construction, we start out with, in the top 6 to 12 inches, we've got a bulk density of 1.7, okay? When you get up to about 1.65, you kind of get across what is called the growth limiting bulk density. Soil is so compact that roots can't actually penetrate into the soil and go down deeper in the profile. And when we get down to the lower 6 to 12 inches, we're even higher. Solid rock is 2.65, just to kind of put that in perspective. Okay, but over time, what we see in our top 6 inches, and we also see it in sort of the lower soils as well, within our beds and our lawns, is that these soils tend to decrease compaction over time. Now, if you remember that reference that I pointed out, the forested soil, that bulk density was 1.23. And so we kind of get back to this stable, if you want to call it natural-ish bulk density or compaction level. But it takes about 30 years to get all the way back there, whether we're dealing with lawns or beds. And so there are natural processes that can help this out, but we'd like to look at how we can accelerate that. And are there ways to improve the soil characteristics for water conservation and just for overall vegetative health? So that's what I've kind of an intro and background of why we are exploring this and looking at the benefits of compost in the soil. So I'm going to be going over a few of our studies that we have conducted that kind of lead one after the other into kind of understanding what's happening with compost incorporation in the landscape a little bit better with each study. So on top of the world, this is in Ocala and Marion County. So we had a few of the master gardeners from there. Within Swiftmud, which is the water management district who controls sort of how much water can be supplied to new developments. The average home water use is about 250 gallons per home per day. All right. On top of the world, communities are pretty proactive and progressive with trying to be efficient and cut down on their water usage. So they actually agreed to a permit of 150 gallons per home per day. And so they've tapped out all the efficiencies inside the home, but they were having some struggles getting down to that 150 gallons per home per day. And really we're getting around that 190 gallons per home per day, and asked us to come in and kind of work with them on how can we conserve water. And we started looking outside the home at the soils. Currently, they've got about 6,500 homes. That number actually might be a bit dated. They might be up to about 7,000, but their long-term plan is to have about 30,000 homes. And so if they want to continue to develop and to fulfill that plan, they want to make sure that there's going to be enough water allocated for those future homes. So it's important to them to make sure that they are staying within their permit and not exceeding that. So this is the very first study that we did looking at it, and it's a model home site. It is by far the best research site that I've ever had, because it's just like the real world, except there's one thing that model homes don't have, and that's homeowners. So it's the perfect situation. It'll never happen again, but it was a fantastic project. All right, so we have 10 homes here, and we use 9 of these. Okay, all of them except for this one, and you'll see sort of in a moment this one, the way this one is on the lot. It's just got sort of a short backyard. It just wasn't working for us. So, and we really only needed 9 for the way we were going to structure the treatment. So what we wanted to do was evaluate, well, how does compost affect the landscape? And in this case, we're growing zoysia, Empire zoysia, turf grass in the landscapes. And we looked at 9 model homes. 3 of these lots we left compacted. So this was basically your standard practice of, everything's compacted. You put in the irrigation lines, you put the sod down on top of it and walk away. 3 of them, we put down basically about an inch, a little bit more of compost, 4 cubic yards per 1,000 square feet of a compost product called Command. And this is produced by Life Soils. We have worked with them quite a bit on our research. They've been great partners, but the use of that product is not an endorsement. So just keep that in mind. There's several other products that are out there, and we'll show some comparisons of the products and some things to consider with selecting compost products later on. But I wanted to make sure, so we have the compost treatment and we have your sort of standard practice, but I kind of wanted to see, well, what if we can get some good benefits from this just by tilling the soil by itself? Because then we don't have to worry about compost. We don't have to worry about kind of managing this additional material. We can get a lot of this, basically, we can get a lot of the benefit translated into practice without having to bring in this whole other aspect of a compost amendment and worry about that quality. So we incorporated this into these treatments were in the top 6 inches, and we did it just before they installed the irrigation system and put down the sod. Okay. The other thing here is that for this study, we just wanted to determine if there was an indication of benefit between these treatments. So the irrigation schedules, the amounts were all the same. So keep that in mind. All right. Now, I'm going to tell you a little bit about soil and water, okay? When we think about soil, how it holds water, it's a lot like a sponge, okay? So if you think about it, you take a sponge off the counter, it's been sitting there, it's bone dry. You put it under the faucet or the spigot, whatever you want to call it, and you loosen it up, you get it saturated, and you pull it out. There's some water that's going to drain right out. Your sponge is not going to be able to hold all that water. Well, soil is the same way. There's a certain amount of water which, when you saturate that soil, that is just going to drain through it. And so that's the blue bars here, and this is basically different fractions of the space or the porosity in the soil. So the blue bars here, what we call free water. And with our sandy soils, we have a lot more of the free water than we do some of the other parts. Now, if you squeeze that sponge as hard as you can, you're not going to get all the water out there. There's still going to be some amount of water that's going to be left in that sponge. Similarly, plants can only take up so much of the water in the soil. There's a certain fraction that the soil holds on to too tightly for the plants to be able to access. And we call this basically the residual water, or it's basically below what's called the wilting point, meaning that when your water content gets below that, your plants are going to wilt. It's because they can't get any water. Now, what really matters though is this green bar here, because this is kind of the water that's in between. This is the amount of water that infiltrates into the soil and stays behind after that free water drains through, but is also above that wilting point. So the plants can actually pull that water and access it, and it's there long enough for them to be able to do that. So with that said, what we found out is after about 2 years of just doing this one treatment of incorporating compost or tilling, we still had effects from these treatments. And the main thing was that we had about 7.8% for our compacted soils. For the tilled, we had about 10.6. But in reality, these values were not different. Okay, it's basically the same. A little bit of a surprise to me, but I'll explain it in just a moment. But our compost consistently throughout this treatment, throughout this study, had about double the plant available water compared to the control and the tilled soils. Now, why do we think that happened? Well, with sandy soils, there's not a lot of structure to the soil. Essentially, if we were to till it up and then we irrigated on it, we put sod down on it, had a little bit of foot traffic on it, that soil essentially reconsolidates or settles back down to becoming the same compacted soil as before. So that's why we see, basically the tilled soil being very similar to our control. The compost basically incorporates these particles of the compost and enables that structure of that soil to remain. So you have all these pores and voids that are able to capture that water and hold on to it and provide it back to the plant. All right, now, how did this look from a turfgrass standpoint? It's like, this is great on the soil properties, but if we're going to get this actually into the development process, the proof's got to be in the pudding, right? So where do we go to? Google Earth. All right, Google Earth don't lie. So here's the thing. We got our 9 lots here. Remember, we left this one out because it's got a really short backyard and all that. I'm going to give you a little test. These 5 lots here, 2 of them were amended. All right, so we go 1, 2, 3, 4, 5. Try and take for a second if you can determine which ones were amended with compost. All right. Everybody got their guess? All right, we're going to reveal the answers. There you go. So you got the amended, and here's our 3rd amended. And if you look, you can tell under the same exact management, even from space, we can see that there is a difference or a healthier soil from incorporating the compost. All right, you can see that there's a darker backyard here, and this one here, the tilled and the compacted, not really a difference, kind of indicating the soil characteristics. So this was great.
Hey, Evan, we've got a question about the compost itself. Was there anything unique about that compost?
So not really. The composting process is unique. They have a unique method where it actually composts in the pile from the outside in. And I would say they do inoculate it with some fungus, some of their strains. But you'll see sort of later on, we kind of did some comparisons between products, and there's foreshadowing here, not a whole lot of difference. Okay, so all right. So coming out of this study, this gave us great hope that there was a potential where we could reduce the amount of irrigation and maintain the same turfgrass quality if we amended these soils before sod went down. Okay. So we went and basically went back to On Top of the World and said, hey, can we do a real world study? Let's bring the homeowners back in. We'll work it out and we'll figure out how to work with them and we'll make it work. And so we included 24 homes here. So our model home study, if you see in this map, our model home study was right up here. And these are the homes that were basically, carbon copies of these going and homeowners moving into them. So we had 24 homes, 9 that we left as compacted or controls, 8 that were tilled, 7 that were compost amended. And we didn't tell the homeowners what type of treatment that they got, okay? They just knew that they were involved in a University of Florida study whenever they purchased the house. And we asked all of the homeowners at the very beginning to reduce their irrigation run times by 25% with the caveat that at any point, if they thought that it needed to be extended, bumped up, or reduced, or if they wanted to change it, they could. We just asked them to start at 25% and let's see where that goes, all right? So again, we applied those treatments before landscaping was put in and also before the irrigation lines were put in. Same compost amendment rate. We also did sort of some, tried to incorporate some top dressing during the year as well. I'm just going to go ahead and mention that that was not real conclusive results that we got, and we're going to be looking at that in the future. But we looked at this basically from July 2018 to October 2020, and we also looked at the runoff volumes and leachate, basically what's kind of coming down from the turf grass and potentially going into the aquifer. So we wanted to, number one, understand, well, what are the consequences of doing this incorporation of compost? Are we actually, we are bringing some nutrients in with the compost, but are we, potentially increasing the amount of nutrients that are going in runoff or leachate as a result of that? We also wanted to look at runoff, runoff volumes, because in the development world, if we can show that there's a runoff reduction, then that's potentially an incentive to the developer to not have to build as large of a stormwater pond, because we're reducing the amount of runoff that's coming off these lots. So another incentive to implement this practice.
Hey, Eben,
Yeah,
before you go on,
sure.
we've got a question about the reduction of run times
Yep.
by 25. So it was 25% off of the neighborhood standard, or?
Yeah, so that basically what they do in OTO is they set it, basically the standard was 45-minute run times. And so which corresponded to the IFAS recommendations. And we asked them to basically reduce that by 25%, so 37.5 minutes for their run times, which equates to a 25% reduction in your irrigation volume. We looked at soil moisture and just kind of to see what's happening in these landscapes. And one of the things that you could kind of tell pretty quickly is we have the compost soils on the top. And you can notice that there's a rainfall event that happens here because all of the soil moisture all goes up at the same time. We don't have sort of, an irrigation event on this house and an irrigation event on this house happen at different times. So the compost here, we see that the water content goes up, and then it kind of stays up there for several days, and it takes a while for it to come down. And notice this is kind of in the range of 0.2 to 0.35. With our tilled, we actually saw that there were some benefits or some better improvement than what we'd seen in the previous study. Some of them did retain water content over a few days, but some of them also kind of had this very sharp decrease. And then in our controls or our compacted soils, most of them had this very short response where essentially water content spikes up, but then it drains through very quickly, doesn't hold a lot of that water, isn't really transferring a lot of that water, making it available to the plants. Okay. Leachate. So this is kind of a little bit of a busy graph, but I'm gonna kind of get to the point real quick here. Essentially, what we have here on our dotted line is the cumulative rainfall depth that occurred during our study. All right. And what we see, you should see this kind of breaks out where we have sort of these orange lines clustered down here. Well, that's the control or the compacted soils. And so what you're seeing is that those soils are actually not infiltrating a whole lot. So there's, if water's not able to infiltrate the soil because they're compacted, if water's not able to infiltrate at the surface because the soil is compacted, you're not going to get water leaching down into the ground. So it kind of makes sense. Above that, we see sort of a cluster of the tilled soils. So we get a little bit more infiltration, and we get a little bit more, drainage that's coming down and moving through that zone. What we see up here, though, kind of a little bit spread out, is the composted lots. So we have a lot more leaching volume kind of going through those soils. So what this indicates is there's only two things that are causing water to go into the soil. It's either rainfall or it's irrigation. One of those we can control. We cut the irrigation back by 25%. This kind of indicates that we should have cut it back even more, because that's what's kind of separating. That's what we can control to adjust this. Nitrogen loadings. So this is a little bit of a concern here, but I'll explain sort of what's happening. This is our leaching of nitrogen, and so again, no infiltration and a lot of runoff. You're not going to get much leaching. You're not going to get much with nitrogen moving through the soil. With the tilled, we had pretty much some increase in nitrogen, and the Y's here indicate whether they were top dressed. Some confounding results on other aspects. We do see that the top dressing tended to increase the nitrogen that was coming through, but also we saw that the compost increased the nitrogen as well. What was interesting is that loading is like, if I'm going to go a little bit into science here, some algebra. The concentrations, which to get to your mass is concentration times volume. Volumes were much higher for the compost. The loadings were higher for the compost treated soils. The concentrations were not different among the compacted soil versus the compost soil versus the tilled soil. So the concentrations were staying the same. So this doesn't become really we're not having high concentrations of nitrogen that's driving these loadings. This is a volume issue. And so the way to address the volumes is getting at the irrigation. All right, so it was significantly higher than compacted. Okay. So from on top of the world, a couple things from here that we saw in these runoff. The compost had lower runoff volumes, and we're getting ready to publish a paper that shows that we can get runoff reductions from using amended soils, and there were no significant differences between concentrations or loadings. The root zone, compost had significantly higher water content. What was interesting is that several of our amended lots reduced the irrigation further to 55% reduction. So they, on their own, without any instruction from us, realized their lot didn't need as much irrigation as was going down. And several of the compacted lots went back or bumped it up even higher above the 100% or the IFAS recommendation. So that was indicative to us. And then the groundwater, kind of touched on this. It's a volume issue, not a concentration issue. So we got to manage the volume by managing the irrigation better. So 25%, right? That seems kind of conservative. All right, so let's see, can we bump this or push this a little bit further? The other question is, how much compost is needed to realize these benefits? We've been going with the 4 cubic yards per 1,000 square feet. Can we get away with 2 cubic yards per 1,000 square feet, 1, and still have some of these benefits? So these are important questions we wanted to look at. And then, do the compost characteristics actually matter? There's a question about the different products. Is there something special about one product versus another? And so with this next study, that's what we wanted to look at. So we wanted to look at, number one, are the material properties among these products very different? So we had 5 products, and I'll tell you that 3 of these products are Scott's products. Another one is Black Cow, and another one is Command. So the things that do seem to be very different are total phosphorus. So you'll notice that our B and C products here had much higher phosphorus than the other products. pH was also higher, or kind of different, I should say. We had 2 products that were much lower, and then we had 1 product that was much higher with the pH. And then there were some that had some outstanding characteristics. So for example, organic matter, we usually want that to be between 25 and 65%. And this product ended up being a little bit higher, 70%, which may indicate that it was a little bit immature as far as compost goes. There's a lot of carbon left over still to mineralize and to burn off. And some of the moisture content. This one was a little bit low. Does it have a big issue? I'm not really sure if it changed what we were kind of looking at here. All right. So this is kind of just looking at what the distribution, the particle sizes were for compost. Really, basically what this is showing is 90% past basically a 1/4 inch. Okay, so these products, as from a physical standpoint, very similar. Okay, you didn't have like one that was very coarse versus one that was very fine. Okay, all right. So we wanted to look at how the soils being amended with different rates and different irrigation rates, and then being with different amendment types, how the soil characteristics changed. So we collected soils at the beginning and end of 2 growing seasons and looked at sort of the bulk density, which is a measure of the compaction, and the soil organic matter, pH, nitrogen, and phosphorus content. And then every week we were basically collecting turf quality. So basically rating, like how healthy is this grass looking based on, you know, the type of amendment, the amount of amendment that went in there, and the amount of irrigation that it's getting. And so we collected a lot of these parameters. I should say my grad student, Ron Fox, did an excellent job of collecting these parameters. All right, bulk density. All right, I'm going to show you several graphs here, or pages of graphs. Each graph is for each amendment type. All right, and then the different symbols are the different amendment rates. So 0 is the black diamond, orange is 1 cubic yard per 1,000 square foot, kind of going just the minimum amount of compost being added. The blue triangle is 2, and then 4 is the green square. And so what we see is that there should be a general gradient in these characteristics from 0 to 4. Okay. And so that's kind of what we see. And these are sort of the results that we have as we move over time. So one of the things, a couple of things that we see is that the bulk density does decrease on its own for all of these treatments in general over time. And we do see that as we increase the compost, we decrease the bulk density, and that was expected. Okay. Soil organic matter. So how much carbon is in the soil, how much is kind of being able to hold on to that water. Again, we should see that, you know, from 0 to 4 cubic yards, we should increase kind of proportionally. And across the board, we definitely see that in each of these amendment rates. Some of the interesting things is that we see that there is in general, an increase in the carbon over time. And in fact, in some cases, we see that as the carbon or the soil organic matter is higher with higher amendment rates, we actually get more nutrients being retained in the soil. Okay, pH. This was kind of interesting. You know, with our soils being oftentimes, you know, higher pH, it might be good to have sort of something that kind of lowers that pH. And so you can see what I've done here is added the dashed line as the pH of the compost itself for reference. And each of these is on sort of the same axes. And you can see that the pH of the control soil goes from about 6.4 up to about 7 in year 2. And that's probably because the groundwater that we're getting and irrigating the source has a higher pH. And so that's kind of where that's coming from. But we do see that our amended plots with the lower pH does seem to kind of buffer that down to about a pH of 7 versus being up around a pH of 7.5 for some of these other amendments. So that's something that maybe we want to look for or try to look into a little bit more. Total phosphorus, some of these are really high, some of these were not so high. We really didn't see a whole lot of difference between the different products. except for here with product B. So product C had, 1,300 milligrams per kilogram. B was about 25% or 30% higher than that. And we saw that that was increasing in the soil as well. What's interesting is that this increase isn't really just at the first data point or the first sampling, which is when the compost was introduced. We're actually seeing that it's happening over time here, and that it's holding on to this phosphorus a lot more. So the landscape crews were still applying some of the typical standard turf grass treatments of putting down some products, and for some reason phosphorus was in there with their fertilization program. But you can see that it's basically holding on to, in this case, a lot of that phosphorus and building it up in the soil. Total kettle nitrogen. We also see that, that this is kind of increasing generally over time in year 1. We do see that it decreases slightly in year 2, and this kind of mirrors our organic carbon. There's some times where it's decreasing over time in the second year, and I'll talk a little bit more about that in a little bit. But in general, most of our nitrogen content was in general fairly similar in the soil. So looking at the turf quality, we had 120 plots. Okay, there's actually 2 studies that we put together. In this first one, we were looking at four irrigation rates: 75% of the IFAS recommendation, or 25% reduction, 25% of the IFAS recommendation, and then we had some plots that were not irrigated at all. Like, can we actually push the limit and hold enough water to where we can just rely on rainfall? We also had 50% from the second study. So if you see these hashed plots, these plots were kind of used in both of these studies that you see. For amendment treatments, the control, which was no compost or tillage, and then 3 commercially available products, A, B, and C. And all of these were at the 4 cubic yards per 1,000 square feet. The second part of the study was looking at the amendment treatments and different rates. Sorry, the different amendment types, where we had 5 of those compost products, and then we had 3 amendment rates. So high, medium, low, 4, 2, and 1 cubic yards per 1,000 square feet. All of these were irrigated at half of the IFAS recommended irrigation amount. Okay, so get to the data, or what were the results? So what we saw here is, well, there were a couple things. We started this study in fall of 2019 with the idea of getting started in spring of 2020. And if you remember where you were 2 years ago today, it was not where you probably are now, because COVID kind of came along and really derailed a lot of the things that we have going on. So we actually had to delay the start of the study through the end of May, which is kind of critical because, at least here in North Central Florida, May is a very dry period. We can have like 0 rainfall in May, and it's also when we're really starting to get high temperatures. So if the turf grass is going to get stressed, that's when it's going to happen in May. So what happened, though, was we weren't able to apply our irrigation treatments until most of the way through May. So they were still kind of getting babied through that first May period. But once June hit, then we had the treatments applied. There were a few places where we had sort of some issues with the equipment, or some leakages going on in the sort of this May time frame as well. So a lot of things kind of happening there, but you can see sort of here in 2021, a lot more representative. We only had 12 inches applied to the 25%, 24 inches applied to the 50, 36 applied to the 75%. Okay. Turf quality. What are we talking about here? What do these numbers mean? So there's a pretty standard rating system for turf quality. So this is the National Turf Grass Evaluation Program. Unfortunately, Ron, my grad student, was very familiar with this from working at Scott's before he came and worked for us as a grad student. And so you can kind of see this is basically, based on turf coverage and the health of the turf grass, we could kind of assign a rating that is fairly consistent from plot to plot or area to area based on the individual person. Now, the standard is that most they usually use is a 6. That's kind of like the minimum standard. However, some other studies, and I think Michael Dukes has kind of led these, kind of looked at it. Most homeowners are okay accepting a 5. So we use that as sort of our threshold of whether we were maintaining acceptable turf quality. So here's sort of we were able to use a drone and kind of get some pretty cool aerial photography. So August 2019, you can see the different colors or shades of gray here. These are the different rates of compost that are put on and tilled in. Some of these plots are not disturbed. Those are our controls. And you can kind of see how that went in. We sodded. And in June 2020, so just kind of coming out of that dry May period and getting our turf, our irrigation treatments applied, you can see that some, again, these are kind of some of our non-irrigated controls, the brown ones. Those are kind of the ones that are most stressed. We kind of go into June, July, August, and we get into September. Everything's very happy. And then we had an early hard freeze in December 2020. You can see it basically went dormant after that. Looking a little bit in the second year, you can see sort of starting to green up in March and May. We still have some good green up. In June, we're seeing the effects of that dry May period and the reductions in irrigation. You can see several of these plots are pretty stressed with the brownness kind of coming through. But then in July, by that time, we get through the June and July where we're getting more rainfall and we're not as stressed, although some of these really took a hit during May and didn't really recover. By September, we didn't realize it until it was a little bit late. And even though we were trying to treat for it, chinch bugs were getting active and basically chomping down on the biomass, and the turf grass that wasn't irrigated as much was really not able to keep up by producing enough vegetation to compensate. We were able to kind of get through that, but you can see sort of in November, there's still quite a bit of damage here in some of our plots. In short, just kind of a note here, we're going to be doing this for a third year to kind of look at how this is going a little bit more long term, probably more like 4 or 5 years down the road in truth and actuality. So kind of getting into some of the results of this part where we're curious about what the turf quality looks like under these conditions. So this is year 1, June, July, August, September, December. We got our turf ratings on the left with our greenness. 9 is like basically Augusta. It's perfect. It's a pro sports, quality turf. 1 is completely dead and brown. This is 100% reduction, non-irrigated, but we had amended it with 4 cubic yards per 1,000 square feet. The bars here represent the amendment type and the average turf rating that it received during that month. This dashed line 5 is the sort of the homeowner minimally accepted. All right. And then this line here, this black line, is essentially kind of like the water balance. The lower that is, the drier that month was. The higher that is, the wetter that month was. So it's kind of like rainfall plus irrigation minus evaporation or evapotranspiration. And then what's the kicker here is if you see these black dots here, we had 4 plots within each of these treatments. And each one of these dots indicates at least 1 plot that failed or basically would have had to go on to recovery irrigation and do reestablishment. So we had at least 1 plot in each of these treatments that had to go on recovery irrigation during even this first year. Okay, so early signs that this is not going to be feasible to not irrigate at all, even given the conditions that we had. Okay. All right, going into year 2, those same non-irrigated, you can see our previous irrigation or our previous turf quality was, a lot of them were still up around 5s. Going into year 2, we're really actually more down around this 2 and 3 level, and really kind of getting into the late summer. We're getting in, the plots are really not doing well. Many of them failed. We didn't put them on reestablishment irrigation for a variety of reasons, but essentially, this hammers home the point that, we're not at the point where amending with compost for 4 cubic yards is going to let us go without irrigation and sustain an acceptable turf quality. Okay.
And Evan, remind me, what type of turf grass is this?
I'm sorry, this is St. Augustine turf
St.
grass.
Augustine.
Yep.
And so
Floritan.
And so that statement is for St. Augustine.
That's correct.
Okay.
Yep. And That's correct. Yep. We haven't tried any other varieties of turf grass with that, but this is, at least for St. Augustine, that's what we've seen. 75% reduction. Okay, year one, we see some pretty good results here. And what we're seeing actually is that the controls are, kind of staying up or kind of doing pretty well compared to the amended plots with the 4 cubic yards. And really, if you look at the turf quality, there's not a whole lot of difference between these amendments. You'd have to be really, really good at being able to rate this to be able to tell the difference between a 7 and a 7.5. Okay, and then you can see sort of in December, this is when we had that hard freeze and everything went dormant. Year two, again, not as good, but we still did, for some of this, kind of get up to the minimal accepted. We do see a little bit of separation, with C being a little bit higher, a little bit better turf quality than our A and B amendments. But if you look at these arrow bars, it's not really significantly different. There's a lot of overlap there. And our controls, only in a few spots were they really any difference between the amended. Going to 50% reduction, so we're trying to be a little bit less a little bit less restrictive with the water going through these. Looking at 50% reduction with 4 cubic yards per 1,000 square feet. Now we're getting up to where we have a pretty sustained turf quality rating of 6.5 to 7.5. Again, very similar ratings during this first year. We're getting more of a separation with the controls, seeing more of a difference there. All of them still staying above that minimum. When we go into sort of looking at reducing the compost amendment rates and looking at the second year, 1 cubic yard per 1,000 square feet, we aren't able to reach that 5 until we get up into June and July, and even by August, we're starting to drop off again with some of these amendments. And we do see some separation here. On average, there's maybe about a 1 turf quality rating between them, but they're not significantly different again. So you see how large these bars are. That's kind of an indication of the range or the spread of the turf quality that you might see within that treatment. Okay, when we go up to 2, again, we're increasing and seeing a little bit better turf quality as we have 2 in this second year. And then 4 is even higher. So we are kind of seeing an effect of that higher amendment rate pushing into that second year. And in this case, we definitely see that there's a separation with the controls, where the controls never have an average above 5 in the second year. But all of our amended plots had an acceptable rating of 5, or in some cases up to a 7 throughout the peak of the growing season. We see a little bit of a resilience effect with A and E being able to kind of hold on to their quality a little bit better in August and September versus B, C, and D. We look at sort of our least reduction, or kind of only looking at 25% reduction at the 4 cubic yards. We've got this is kind of our best scenario within what we were treating. We're still looking at, pretty good separation between our control and our amended rates, our compost types. Not seeing a lot of difference really between the amendments themselves. Pretty standard, pretty typical. Going into the second year, maintaining just a 25% reduction, we're even able to get to the control plots up above this 5 minimum with that 75% of the IFAS recommendation. But the amended soils in several cases are staying up a unit or so above the control, except for in July with B and C, where these kind of drop back down. And some of these, this may be the effects of some of the chinch bugs, but in this case, A was able to maintain that the A minimum was able to maintain a better turf quality through that part of the year. Kind of boiling this all down on all those graphs, this is the last graph, almost the last graph for a while. So here we go. Irrigation rate percentage, 25%, 50, and 75%, going from low to high here, and looking at our amendment types A, B, and C. In 2020, everything was kind of doing pretty well. We saw a little bit of a better separation as we got to the higher amendment rates, but not a whole lot of difference between our amendment types A, B, and C. In 2021, most of our 25% irrigation ones did not meet a minimally acceptable criteria. So our 50 and 75% are the only ones that we're showing here. Again, not a big difference between our amendments, although because of that late season resilience of the compost product A, at the 75% irrigation, you can see that there is a significant difference there between the B and the C amendment types. Looking at the amendment rates and the amendment types here, we see in year one, not a lot of difference between those amendments, but everything is essentially as you increase your compost rates, you are getting a benefit of better turf quality. And we generally see that trend as well in 2021, but there were definitely some differences in that second year that were that seemed to stress the turf grass more so than what was happening in year one. So we had some reduced turf quality for all of our treatments, but you can see in the 4 cubic yards per 1,000 square feet, all of those averages were above the minimum 5 of the rating. And some of them even at the 1 and 2 were able to maintain above that minimum rating. To kind of look at sort of what was happening between these 2 years, if you look sort of at these 2 plots of the rainfall that happened between July and September of 2020 versus 2021, a couple things should point out. There wasn't a lot of difference in the total amount of rainfall we got, but there was a big difference in how it arrived. In 2020, we had more regular rainfall events. So you see sort of pretty regular, a lot of these half-inch or less rainfall events occurring. A lot of shorter duration between events, so only maybe a day or 2 happening. One of the things that one of our landscape guys talks about is we're only 2 days from a drought, right? And that's in the summer. That's kind of what's happening in our landscape situation. In 2021, that's kind of what was happening. We were getting a lot more of these larger events with longer periods in between those rainfall events, which we think was the reason why we were starting to see more stress occurring in the turf grass and causing a lower turf quality compared to year 2. But this is also why we're wanting to extend this study and look at year 3, 4, 5, and 6, and so forth, hopefully down the line. A couple things to kind of come out here. Benefits of compost seem to diminish with the increased rates. So one of the things that I didn't touch on as much, but you get a big benefit from 1 cubic yard kind of coming in, and then you have a little bit less of a benefit from 2 cubic yards, and then you get a little bit less of a benefit in general when you get up to 4 cubic yards. But 2 cubic yards per 1,000 square feet seems to be sort of a sweet spot as far as the benefits that we get from the compost, and also not putting down more than we need to. Non-irrigated and 75% reduction on irrigation, 75% reduction of irrigation on the turf plots has not proven to be feasible. None of our non-irrigated plots for St. Augustine were able to survive. So we're not at that point where we've got sort of a silver bullet that can improve the soil to the point to where we don't need to put in an irrigation system to help it survive, at least early on. But it seems like 50% reduction is feasible, fairly feasible in most of these situations. In our amendments, kind of getting at the differences, the amendments are fairly similar. And so our recommendation is to look for products that meet the U.S. Composting Council seal of testing assurance. A lot of time you can kind of find this on the bag if you're getting it from a big box store. And all of the products that I mentioned are either approved by the SDA or their characteristics are within those ranges. So the Scott's products, the Black Cow, and the Command, their Life Soils Command product. We did see sort of some differences that came out, the varying pH. So that was one thing where we had some of the products have a pH at around, upwards of around 8, whereas some other ones were down around 6. And that may be a benefit if you've got a soil that tends to be a higher pH and you want to kind of drive it down. It may not stick around for forever. In all likelihood, it probably won't, but it might be something that benefits over the long term or over a short period, I'm sorry. And then phosphorus rates were kind of variable, and that may be due to the feedstock. So if they're a black cow, a lot of that comes from horse bedding and horse manure. It's got a kind of a higher phosphorus loading to it. So yeah. So I am kind of right at a kind of the critical point where I wanted to not go too long, and I've got one sort of a few slides that talk about top dressing and then some resources we have. What do you think? You want me to keep going, Wendy?
I do want you to keep going because
Okay,
some of the questions are about top dressing.
great. All right,
Because they want to think about, okay, I have an established landscape. How can I do
right.
this?
Yep,
And then when we get to the questions, we're going to kind of go like speed round with the questions.
perfect. I got it.
Okay.
Okay, so so top dressing. This is an area where we're so with the amendments, that is the tilling in of that of the compost before the sod goes down. So it's not something you can kind of go back and amend an existing landscape. Top dressing is what we're talking about now. Top dressing is basically putting down about a half or a third of a cubic yard per 1,000 square feet, which is an eighth or even a 12th of what our standard amendment rate is into the soils. Okay, so we're talking about much lower rate that's being applied. That is a little bit finer, actually. So the idea is that you spread this out, and those particles kind of sort their way in between the blades and work their way down into the soil. And there's some nutrients in the compost, but some of that carbon also kind of hopefully gets incorporated into the soil. Right now, all we have is sort of anecdotal data of what the impacts are, and can we translate this to water conservation, or what are the water quality impacts? We did do a little bit of this study with On Top of the World, but as I mentioned, those results were not very conclusive, and they were kind of confounded. But sort of anecdotally, what are we seeing with top dressing? So this is kind of something we definitely see is the early green up. And you see sort of one side of this yard that is treated or is top dressed, the green side, and the other side that is not. Okay, so there is definitely a benefit that we see in the quality and the health and green up. One of the other things that was looked at, this is sort of a small study that was done in the villages and looking at soil fertility. Basically, they looked at 1, 2, and 3 treatments per season of the top dressing, and it seems like 2 treatments per year is kind of the sweet spot. If you see, for example, the organic matter, 1 treatment per year, 2 treatments per year, 3 treatments per year. This blue bar is sort of the after, and if you kind of look in comparison, the mean before is the orange. You can see that there's a diminishing return as you go with more, but kind of 2 seems to be that sort of sweet spot. Soil pH, didn't see a whole lot of difference here. We didn't actually get measurements of the compost itself, but in all indications, we had a slight drop in the pH due to the application of the compost. So it probably had a more acidic pH there. And then phosphorus, we see that there is, you get a bump in sort of the amount of phosphorus that's available to the soil and to the plants. But again, we sort of see that chopping off at about 2 times per year. We are looking at sort of a study that's going on right now where we're looking at 20 different lawns and looking at the water quality effects in the leaching through the soil profile. And looking at sort of compost top dressing, synthetic fertilizers versus organic biosolids, or some that have no fertilizer, some that are natural areas, and so forth. So we're trying to get at this problem and trying to understand what is number one, what are the environmental impacts, if there are any, compared to the standard practice, which is typically your synthetic fertilizer. Is there a benefit? Does it hold those nutrients longer? Does it allow the plants to take it up more efficiently? Trying to get out that question. One other thing that we're looking at that we're going to be starting later this year, we have a grad student who's in place, who's going to be looking at, similar to our previous study, looking at irrigation reductions. We're going to be applying top dressing and also looking at conventional fertilizers and looking at, can we sustain the same turf quality by doing top dressing and with a reduced irrigation. So we're hoping that in the next year or two, we'll have some of those recommendations as far as for these existing landscapes that, it's great that there's 1,000 people coming to Florida every day and we can have maybe a recommendation for those new homes, but there's millions of existing homes here that we want to be able to try and have an impact on as well. So it's on the way. I'm just going to point here. I have some resources. I'm going to give those to Wendy to post on the website because I see that y'all can kind of do that. This is a guidance for amending those landscapes for professionals, or if you want to do it at home. We also have this is a field sheet that goes along with it and how to check it off and so forth. We have an example ordinance for local communities to require this as part of their development process with recommendations in there. I'll also have a link to that. And we have a tool that we're developing for the development community to look at the cost benefits. You're saving water, you're saving money. And how does that translate to the homeowner? Will a developer be able to invest or put that in, pay the cost, which is, somewhere around $1,000 per home. Will they be willing to spend that if it can translate into cost savings that they can market to the upcoming homeowner? All right. So with that, a lot of people that have helped out with all of this throughout the years. I only did a fraction of this. These guys did all the heavy lifting. People from our department, grad students, soil and water science, the program for resource efficient community, Life Soils, Harvest Quest, and several of our funders, Tampa Bay Water, Swift Mud, the Florida Turfgrass Association, and FNGLA. We couldn't do what we're doing without those partners. They're just so good to UF-IFAS. And so I kind of rambled through that at the very end. Happy to.
Good. Well, we've got a lot of
questions.
questions. I'm going to let you catch your breath, and I'm going to answer one of the questions that was out there that Candace Hoke from Orange County asked. And she said that a lot of our Master Gardener volunteer materials and Florida Friendly and UF materials recommend not composting when planting shrubs and turf and trees. And Candace, what we recommend is not putting compost in the hole. The way that Eben showed us, which was to apply compost over the whole planting area, is what we're talking about as a recommendation. So that is recommended, but putting compost in the hole is not recommended because the organic material burns off so quickly. We can get air pockets, we can get the plant dropping and sinking too deep in that planting hole. So if you are going to plant or compost at planting time, we do a top dressing. And someone asked what top dressing is, and that's basically sprinkling at about maybe an inch deep of compost and working that into the top of the soil. Okay, so
sometimes it's combined with aeration, where it kind of pulls the plugs and the compost can kind of work its way into the soil through those holes.
Okay, good. All right, so here we go. For the last study, not the villages study, but the one in between, were those plots fertilized?
They were. That's sort of something that was.
And what kind of rate was that? That's
They
Dina.
followed the standard recommendations for UF-IFAS with
Okay.
their standard turf grass maintenance program. That was at our Citra Research and Extension Center.
Okay, and then Janice is wondering, 1 to 2 cubic yards of compost. What is that going to look like inch-wise? How many inches is that?
So 2 is about. So 1 inch is about. 3 cubic yards is about right at 1 inch. 4 cubic yards is about 1.3 inches. 2 then would be about 2/3 of an inch.
2/3
and then 1 cubic yard is about 1/3 of an inch.
Okay, great. And then what time of year, if you were just going to casually tell us, if you want to do a 2/3 of an inch top dressing on your turf, what time of year would you recommend doing that?
It depends. I mean, if you want to get the green up, you want to see that, then probably this time of year. Maybe it kind of depends on when your temperatures start to get warm enough where you are in the state, but kind of in that when the grass starts to wake up. But usually, kind of early in the growing season, and then kind of, in the middle of the growing season. So it can kind of stretch in between those two periods, because compost is going to stick around for a while as it kind of mineralizes. Some of that carbon and the nutrients are fairly resilient, and it takes a while for the organisms to kind of break that down, but it tends to slowly release those nutrients over time. I like to say that it's the original slow release fertilizer, to be honest.
Okay. And then Judy wants to know, are some of the yard maintenance companies beginning to offer this as an alternative to fertilization?
Yeah, absolutely. And that's one of the drivers here is if you're familiar with Massey, they're kind of one of the early adopters. They've actually transitioned and as I understand it, still, still offer this. They like it because and I believe I hope I'm not speaking wrong here, but they have sort of a subscription sort of service
Okay.
where they if they come out and put out the top dressing, um, they they basically, sorry, let me back up. They don't get paid every time they come out. So if they're putting out the top dressing and they don't have to, it's healthier soil, they don't have to, they're not putting out a lot more nutrients, then they don't have to come out as long often.
Mhm.
So it's actually a cost savings for them because it's improving the soil from what I understand anecdotally.
Okay. And then what effect do pesticides have on the soil and the soil microbes?
We haven't looked at that yet, so I really can't say with any, I can't really speak to that, to be honest.
Okay. Okay. And is anyone looking at compost tea?
We do hear about that from time to time. Yeah,
Okay.
where you kind of have the water or the liquid that kind of comes out of that compost, and they bottle that. Typically, kind of using it as almost like uh, a a sprayed on conditioner for the turf grass. And they'll kind of sometimes they can inoculate it with some microbes. We haven't done any studies to kind of look at that, and I'm not haven't really looked at that as a what the research is out there. Um, just because it's such a small volume that you get relative to the compost material that you get. So it's kind of tends to be more on the pricier side for the nutrients that you're getting and the effect you're getting.
Sure,
You
sure.
don't get the organic matter kind of there.
Right, right. So Lynn asked very early on at 1:15, she asked. She had recently read about PFAS in compost products.
Yep.
And that's one thing, that's that chemical. And then I'm also concerned about the herbicide coming through in cow manure. That so how can you comment on that?
I can say that we are looking, I'm on a project with a colleague, AJ Reisinger and Chris Wilson from Soil and Water Science.
Mhm.
We are looking at that. I don't know that I can comment on the results yet, but I would say that, we talk about PFAS being one of those forever chemicals, the way that those chemicals, there's not a whole lot of processes that break that down. And so however they get picked up into the streams, whether it's like a waste stream or being taken up by a plant, you're getting that it's getting distributed into a lot of the different realms of our life, unfortunately. So yeah, it's something that you're seeing kind of everywhere. We don't see that composting is, I will say this, we don't see that composting is, you know, breaking release or sorry, eliminating it or yeah, we don't see that it's eliminating. I'm not sure if composting helps to break it down. We haven't really looked at it specifically, but we were looking at sort of does PFAS kind of, is there some PFAS in these materials and is there
Yeah.
some that's available? I will say that it's very low concentrations that we've found.
Okay.
Um, and that's probably about as much as I could say at this point.
Okay, at
So
this point. Um, do you think that the changes that you saw would be different if the lots were not flat?
if the lots were not flat,
If it was hilly or angled?
mhm, not not really, because actually these lots in on top of the world, um, they actually did have some slope to them. Some of the ones
Okay.
that in different areas, um, and we didn't really see much of a difference with that. I think what we see, so if you think about it from one aspect, the slope side is going to allow a little bit more runoff to occur if you have excess water to what can infiltrate into the soil. Okay.
Okay.
Um, if the soil has high enough infiltration rates, though, there's not going to be a whole lot of runoff being produced. So there's going to be sort of these extreme events where we have just a downpour and it just overloads the soil because you got the rooftop and the driveway running into the yard, right?
Mhm.
But because on a regular basis, you're kind of getting the same effect, the same amount of sort of water kind of contributing to the landscape. It's holding that water similarly, whether it's sloped or not. I wouldn't expect there to be a major difference between those.
Okay. Um, Rich asked also early on, can we place the top dressing on an established lawn? If so, when and how much? And from what I heard you say, spring for spring green up, maybe again later on in the summer, and we
Yeah.
would put on about 2/3 of an inch depth.
No, that's way
No,
too much, Wendy.
too much. Okay.
Yep. So with top dressing, it depends on the type of turf grass you have. And I'm going to get it, I worry that I'm going to get mixed up, but um, St. Augustine, let's see, zoysia is half a cubic yard per 1,000 square feet. So which actually comes out to be more like a tenth of an inch. It's very, very, very small amount because it's got to get in between the blades
Mhm.
without kind of packing it down.
Right.
And then a third of a cubic yard per 1,000 square feet. Well, I'm sorry. So half of a cubic yard per 1,000 square feet is like 0.15. A third is like a tenth of an inch. So kind of in the, thinking
Okay.
about depth. But yes, spring for the first one, and then summer for the second one.
Okay. Also, did you all, people are very interested in what those products were, specifically A, B, C, and D.
All
And
right.
then if mushroom compost was involved at all.
No, we haven't looked at mushroom compost.
Okay.
I'm familiar with that being definitely available as a product. Um, A was Black Cow, B was Command, C was a Scott's product. It was C, D, and E were Scott's products. So when we
Okay.
did A, B, and C, we were comparing sort of the main product of Scott's with the main Black Cow and the main Command. And then we had A, B, C, D, and E. D and E were kind of a little bit different. One of them was kind of like a soil and compost blend a little bit, but both of them were kind of compost based materials.
Okay. And then Janice, who I think has left, but we'll go ahead and answer it anyway.
Sure.
She was thinking about the second year of the study, the
Mhm.
nutrient benefits of the amendments had either maybe they had run off or they had been absorbed or used up. Is that why you saw the drop off?
No, I don't think so. I think it was due to the frequency of rainfall that we were
Uh-huh.
seeing and the ability of the plots um, to be able to hold on to and continue to provide water to the plants. So you think about it like a bucket. All right. So if we have a rainfall event, the bucket fills up. If we have five, and the plants are going to take a little bit each day. And so if we have to, spread that bucket out, over 3 days, and that's about how much that bucket can hold, then if we're having, filling that bucket up and then we have 5 days in between, that's sort of what's happening. And it's going to take, 2 extra days if we don't have water to be able to provide to that plant. So it's going to stress that plant. And then it's going to take some recovery period for that plant to kind of come back. And then you come at it with, again, a rainfall event. We fill up the bucket, but then, again, 3 days later, we're out of water again. And it was just starting maybe to recover. It's going to continue to kind of drop down a notch over and over. So the ones that were not amended as well, we're not getting as much supplemental irrigation. Those were the ones that were suffering the most.
Okay. There's this product out there called Hydratane. It's
Yes.
a soil
Yep.
coating of
Yep.
sorts. And
Mhm.
has UF kind of looked at that for reducing water use?
We have not yet. We have
Okay.
not. I am familiar with it, and it seems like it has some very promising product, but I'm not aware of UF doing any studies with it.
Okay. And then when applying that if we're starting a new yard or a new bed, applying that top dressing or of compost, should we till that in or should we just leave it on the top?
So if you're prepping a new area, to put down sod. Say you had like say your landscape failed and you want to come in and replace it. You wanted to spread out the compost, whatever, at least 2 cubic yards per 1,000 square feet. Till that into the top 6 inches, and then put your sod on top of that.
Okay.
If you don't incorporate it, what we see kind of happening is roots will go into that layer of compost that's above the soil, but then it won't go much deeper than that.
Yeah, I know. I like to stay where it's real comfortable and rich also.
Absolutely.
Um, and so one of my questions would be composting like this or top dressing with compost like that, would that be exempt from any fertilizer regulations that might exist in a county?
It's my understanding, yes, that the top dressing with compost is exempt from fertilizer blackouts in most places.
Okay.
I worry about saying that as a blanket statement for
Okay.
all places, but
So sure,
check with
people,
your local regulations, but I
there you
believe it
go.
is.
There you go. Oh, that's great. And Kathy kind of asked sort of a abstract question. It
Yeah.
looks like tilling in compost for new lawns is helpful for water conservation.
Mhm.
No-till farming is being recommended for carbon sequestration and climate control. How can you kind of weigh both of these?
Yeah. So what happens with no-till farming is that you kind of build up this organic matter, and that creates a structure in the soil. And then when you till it, it's kind of breaking that up and exposing it to, a lot more of the drying and wetting, drying things that'll basically burn off that organic matter. In this situation, we're starting with basically nothing. Okay, the soil in most cases is almost barren of organic matter, so there's nothing in there for us to lose. Okay, so we're getting the benefits by basically mixing that compost into the soil. The compost particles are providing some structure that allows for that soil to we're kind of kickstarting the natural process that occurs in soils where there's organic matter that's building up and it's kind of being incorporated into the soil structure. After we do that, we're not going back and then tilling it again. So we kind of have that no-till situation after we put the organic matter in there. If we didn't put the organic matter in there, though, through the tillage process, it would just it takes decades for that process to actually kind of occur. So we're not tilling it and destroying the organic matter because there wasn't anything there essentially before. Okay.
Okay, good. And then, there's some questions about mycorrhiza, and what I'm excited about is that Chris Wilson is going to be speaking to us in May. So I'm going to let him talk about the soil life. So
Okay.
anyone wanting to talk about the soil biota, we're going to have an amazing specialist joining us later on in the year. And let's see. Would these treatments be helpful to stressed grass where pre-emergence has been applied, or, would you? So if your grass has been stressed out or dying, could you kind of revitalize with the type of
Top
compost we've
dressing?
been talking about?
Yeah, I think that top dressing would be worth trying. And that's actually something, I mean, I don't pay somebody to come and do it at my yard. I'll go and pick up compost at the at the big box store and put it out in my yard and kind of rake it in. If I'm seeing more sort of some areas that need to have a little bit of a boost. So I think that, yeah, there is a potential there to improve it. We don't have the data that really shows that from the top dressing, other than the early green up, the improved availability of nutrients, the improved organic matter kind of things. So it's a little bit of a reach, but it is kind of substantiated by some of those other results.
Okay. And then Brenda wanted to remind us that a lot of times we need to call before we dig. If there's any utilities or lines underneath, you of course will find them as soon as you start tilling. So to be careful with that.
Absolutely. And so one of the keys in the order of the process here, you wait until the very end of the construction process on that end, because, well, the only thing that's not in utility wise are your irrigation lines, because that's the only thing that's within that top, usually that should be, I should say, within that top 6 inches, other than if they're running cable and your cable person hasn't buried it. Everything like water, electricity, and sewer and gas should be deeper than 6 inches. So it
Right.
shouldn't, but again, I agree. Call before you dig. Um, with the top dressing, that shouldn't be an issue on an established lawn.
Okay. And I think I'm going to just do one more question, which
Mhm.
is any plans to compare water fertilizer usage with native non-turf ground covers? So like the study that we've had going on down in Lake County and
Mhm.
beyond and over in Osceola County.
Yeah, I think some of my colleagues are looking at some of those types of questions. Basil Iannone kind of really looking at that. Um, and kind of trying to quantify some of those benefits. You mixing, even looking at mixed turf species, like is that a potential solution as
Right.
well?
Right.
So yeah, I can't remember if he was in your series of speakers, but yeah.
Not this year. And the
Okay.
last time we had Basil was more about, basically, ecosystem services
Oh,
and ecology in a landscape. So we'll have
oh,
to have him
absolutely.
back for the kind of his native ground cover studies. Now
Yeah,
I'm excited that it's studies now, not just
that's true. Yep.
so it's exciting. Well, Evan, we've had a really excellent education from you. We appreciate you sharing your research and the outcomes and kind of where things are going in the future. And I think that we're going to really see this start to take off as an alternative in our urban landscapes. And everyone's saying, excellent talk, thank you. And I'd like to let you know that right upwards of about 260 people were hanging with
Oh my
us even
goodness.
through all your charts,
Wow.
which they were fascinating, but just most of the time we like to look at, pictures.
Pictures. I know. I know.
But we love the charts because they told such a terrific story. Everybody loved it. So thank you. And we will see you next time.
All
Thanks
right.
a lot.
Thank you so much.
All righty. Bye bye, everybody. See you next month.